This is Yubin Ko from C Block. My research question is: does being an athlete impact on the number of absentees due to bad health conditions? The variables are the number of absentees due to bad health condition, which is a quantitative variable, and the type of data is discrete as there is an exact number when measuring the variable, which is the number of days. There is two population, non-athletes and athletes. Athletes have sample size of 6, while non-athletes have sample size of 5. I have used stratified sampling, and this represents the C-block math class athletes proportion. In addition, in the two variables, the proportion of males and females were measured again for each athlete and non-athletes for higher precision. Stratified sampling is a sampling technique that involves dividing the population subgroups, then selecting a sample from each stratum. This method is used to ensure that the sample represents the diversity and the characteristics of the entire population more effectively than other sampling techniques. This method increases representativeness, and stratified sampling helps ensure that the sample accurately represents the population's characteristics. By dividing the population into distinct strata based on relevant attributes like gender, each stratum can be represented proportionally in the sample. This helps to capture the variability and diversity present in the population more effectively. By sampling from each stratum, the variability within each subgroups is reduced, which can result in more precise estimates of population parameters. Stratified sampling allows for meaningful comparisons between the different subgroups within the population, which is athletes and non-athletes, and their number of absentees due to bad health conditions. By ensuring an adequate representation of each stratum and draw valid comparison and make reliable inferences about differences or similarities between groups. The size of the sample used to calculate standard deviation and variance can impact the reliability of the conclusion. With small sample sizes, the estimated standard deviation and variance may not be representative of the entire population. The conclusion drawn from such limited data may be less reliable and subject to larger sampling errors. Sampling errors can affect the precision and accuracy of the estimated population parameters. With larger sampling errors, the sample statistics may divide significantly from the true population values. As a result, the conclusion drawn from the sample may not accurately represent the entire population, leading to potentially misleading findings or generalization. Coverage errors are shown as I have only collected data from C blocks and not the whole G block students, which is lack of reliability of the data. And coverage errors can introduce bias into conclusions because the sample may not accurately represent the target population. If certain groups are systematically excluded or underrepresented, the conclusion drawn from the sample may be skewed or fail to capture the true characteristics of the population, which is athletes and non-athletes in the extended math class. This can lead to biased estimates, inaccurate inferences, and limited external validity. This is my raw data. It shows the name, the number of absentees, and whether they are athletes or non-athletes. The column graph at the above shows the number of absence by non-athletes, while the one at the below is the number of absentees by athletes. This is the frequency table. The table on the left is about the athletes, and the one on the right is non-athletes. For athletes, the column graph is right skewed as there is a high frequency in 0, number of days in absentees, and 10, 14, 15 days of absentee at frequency of 1. Mean value for athletes is 6.5, median is 5, mode is 0, maximum value is 15, minimum value is 0, lower quartile is 0, upper quartile is 14, the range is 15, and the interquartile range is 14. Lower quartile is 25 percentile, while the median is the 50th percentile, and the upper quartile is the 75th percentile. Range and interquartile range measures of spread only takes into account same values from data set, Therefore, some datasets can have their spread characteristics hidden when only the range and IQR are used. This is why variance and standard deviation is used to measure the spread too. Variance of data set is the average of the square of distance between each point and the mean, which will be shown in the next slide. The standard deviation is 6.68, while the variance is 44.58. For athletes, the lower boundary is value below -7, while the upper boundary is value above 35. Hence, there is no outliers as all the datasets sit between -7 to 35. For non-athletes, the graph is also right skewed as there is high frequency in 0 and there is a decrease from the increasing number of days of absentees. The mean value is 3, median is 4, mode is 0, maximum value is 6, minimum value is 0, lower quartile is 0, and upper quartile is 5.5, range is 6, and interquartile range is 5.5. The standard deviation is 2.53, while the variance is 6.4 exactly. Also, for non-athletes, the lower boundaries is valued below -2.75, and the upper boundary is valued above 13.75. So the data set sits between the two values, so there is no outliers. Athletes have a greater center than non-athletes. Since the mode is the smallest value 0, this is not suitable to be used for comparison of greater center. The mean and the mode of athletes were higher than the mean and the mode of non-athletes. Standard deviation and variance are both measures of dispersion that quantify the spread of data points in a population or sample. The larger the standard deviation or variance, the more varied the data is considered to be. To compare the variability between two populations using standard deviation and variance, I calculated these measures for each population and then compared the value. Athletes has a higher standard deviation and variance compared to non-athlete. This indicates that the data points in athletes are more spread out, showing greater variability. From all of this, I can see that the non-athletes have a lower frequency of absentees due to bad health condition than the athletes. However, this may be due to the athletes having more frequent contact with people outside of the school community and have gotten COVID-19 and has to go through quarantine of 14 days. Unlike non-athletes who have less contacts with people outside of the school community and have less contact with the people overall because they usually stay in the school and stay with the same people that they meet every day.